Good morning. This is Dr. Joel Shertok, President of Process Industries Consultants, a chemical engineering consultancy located in Newark, Delaware. And this is one of the continuing podcasts that I am developing to talk a little bit about the chemical process industries. In the past, we've discussed technology, we've discussed separations, we've discussed how the evolution of the CPI has played out over the last 50 or 60 years. Today, I want to talk about issues that sometimes get glossed over during chemical engineering education. And this is the concept of safety and EHS, environmental and health and safety. These are actually very important factors in the chemical process industry, since by definition, many of the operations that are carried out within the CPI have a certain hazardous component. You're dealing with chemical reactants that may be poisonous. You're dealing with mixtures that could be explosive. You're dealing with people who are fallible and may make mistakes. And to have a safety culture sometimes flies in the face of running a plant to make money. People who run chemical plants, from the CFO to CEO to the plant engineer, understand that when a plant is not running, is not making product, it's not making money. And if it may not be running, but you still have personnel who are getting paid. If there's no income to supplement what they're doing, the company's in a world of hurt. Let's talk about the importance of safety, talk a little bit about my experiences, and you could see, or will see by the end of this little chat, why EHS and safety are so important to the smooth operation of a unit. Own personal experience. This is the Bhopal incident in India involving a union carbide methyl isocyanate plant. It is probably the classic example, and the implications and the results are incredibly dire. So in December of 1983, in the evening, in India, Bhopal, a methyl isocyanate plant, which is used to make insecticide, was running normally. And for some reason, someone, either maliciously or accidentally, put water into a methyl isocyanate tank. That immediately caused the creation of cyanide gas, standard chemical reaction. Now, this plant in India had 4 different backup systems to prevent this from happening. To basically contain the cyanide, to neutralize it, to sound the alarm, what have you. So people felt pretty secure. But it turned out that none of these systems were operational. They were never checked, they were never tested. People assumed that they were there and they would work. And that turned out to be an absolute total disaster. It killed perhaps 3,000 people, and people not even associated with the chemical plant. The plant was located within a pretty densely populated area. It happened in the evening, and people had no chance. I mean, it killed them in their sleep. And those who were not killed were severely injured. The fumes coming off were no joke. And more than the poor Indians who had killed, it destroyed a company. For those of us who lived through Bhopal and the implications from December 1983 to middle of 1985, it was just one disaster after another. It was absolutely amazing. We who had worked for Union Carbide assumed that it was a secure company, well managed, and it turned out to be the case. It was running negative cash flows. There had been issues, and the management was able to operate and take steps to make it seem it was a healthy company. But when Bhopal happened, a lot of private equity firms made a run at Union Carbide. They smell blood, and their job is to pick up assets on the cheap. And one particular guy made an all-cash, multi-billion-dollar offer for Union Carbide. And the management decided that rather than let this guy take over the company, they broke it up. They broke it up into pieces and sold off the different pieces to make a better cash offer for the stockholders. And I often say that the guy who put the water into the methyl cyanide tank destroyed a company and destroyed 100,000 careers. Up to December 1983, people who worked for Carbide had a clear path forward. They understood what they were doing. They knew where they were going. And after December 1983, no one had the foggiest idea. And it took a year to play out before all the pieces kind of fell and everything was sold and or kept. But reduced Union Carbide from a $10 billion company to a $1 billion company, and from 100,000 employees to 10,000 employees. And the remnants of Carbide were eventually bought by Dow. Union Carbide today is a division of the Dow Chemical Company, which is an extreme humiliation for anybody who was an employee of Union Carbide. So let's just say that the importance of a safety culture is demonstrated by this Bhopal incident. Now, Bhopal is pretty major, but there are all sorts of interesting stories that also demonstrate the importance of safety and wise operating procedures. I worked for one plant in New Jersey, and it was operating at a time when the chemical industry was going absolute great guns. I mean, it was just minting money. It was a great time to be in the chemical industry. And the plant was scheduled for a maintenance shutdown. Now, plants wear out, and they need be shut down, replacing, refurbishing, just like anyone's automobile. And the plant manager said, I have to take a shutdown. I've got to, I'm running on the ragged edge. And the powers that be said, oh, no, you can't do this. You can't do this. You can't do it. We're making too much money. Don't shut down. Don't shut down. And every time he tried to bring it up, he was told, nope, keep on running. Keep on running. So you can imagine what happened. One day, the plant had to shut down. And it's like your car. If you do planned maintenance shutdowns, which is say bring a car into your local service center and get it fixed, repaired, and otherwise maintained while it's still in running shape, no problem. You take a morning off, it gets the oil change, your tires are fixed, et cetera, et cetera. However, if you don't do this, one day in the evening at 12 o'clock at night, your car will break down in the middle of nowhere. And you'll have to call AAA, if you're lucky, to come bail you out. And of course, it always happens on a cold night when it's snowing and icy, et cetera, et cetera, et cetera. And the same thing happened with this plant. It shut down at the worst possible time, of course, to do repairs that basically could not be delayed anymore. And the poor plant manager was blamed by this very same people who refused to let him shut down, and he's removed. Because how dare you let this plant shut down? How come he didn't do a maintenance shutdown? How come? So the guy would have been much, much better off saying, I don't care what you guys say. I need a maintenance shutdown. I'm going to take it. And we'll start back up. We'll be in great shape. So safety is important. So how does CPI get involved in a safety culture? You go back to the deep, dark 1960s, and there was not anywhere near the emphasis on safety in the CPI. Union Carbide ran a plant in South Charleston, West Virginia. It crossed over, and there was a bridge that crossed over the Kawan River into the plant. It was built on an island. And it was so bad that cars going over the highway had to keep their lights on at high noon. It was so, the amount of air pollution coming out was bad. But people worked there because at that point, the only alternative was, of course, working in a coal mine in West Virginia. And getting sick and dying of cancer at age 55 was infinitely preferable to being caught in a mine cave-in when you were 20. But through a bunch of environmental actions, through a lot of sensitivity, and indeed through chemical executives realizing, where their bread was buttered, very, very gradually, an idea of safety culture began to permeate into the chemical industry. At Union Carbide, the wake-up call was 74, roughly, and a workman was cleaning out a paint blender. Paint blender is not more than a big tank with a really, really strong agitator to blend very viscous liquids. At this time, there was nothing called a lockout tagout procedure. So the guy was inside, he was doing his repairs. Nobody knew he was there, or those who knew he was there didn't think anything of it. And a supervisor came by and saw that this paint blender was off. He said, "Hey, who turned this damn blender off? It should be on and running." And he hit the on switch. And the only thing good about it is the guy probably was killed before he knew what was happening. But basically, it was blended operator. And that's what happens when you don't have those procedures. And that opened up a lot of eyes at the unit, and slowly began to change. So what have you now? You have material safety data sheets. You have bills of lading. You have the EPA. You have OSHA. So I remember when I first started working for Carbide, and this is like 75, I had to ship samples of cumene hydroperoxide in that 40-50% concentration from the chemical plant in Ponce, Puerto Rico, up to Union Carbide's Boundbrook facility so I could do some analysis on it. And there was an outfit called Profit by Air, and they said, "Hey, we'll ship your chemicals for you." And that was important because cumene hydroperoxide, as you can imagine, is perishable. It decomposes. And for this to be successful, it had to be a fresh sample. So this Profit by Air basically took my samples, wrapped them up, put them in a picnic basket, styrofoam, and shipped it up. No bill of lading, no warning, basically the same way you'd wrap up bologna sandwiches. And it was fine. It worked great. I got my samples, got the analysis. But during one shipment, the samples began to leak. They weren't properly tightened. And the picnic basket began to dissolve. Now, fortunately, it got to us before anything leaked out. But we opened up our package, and the picnic basket was half gone because the cumene hydroperoxide was dissolving it. These days, if you did that, you would probably be arrested. The DOT would come after you, OSHA would come after you, EPA would come after you. And this is all a consequence of safety culture. But even now, there tends to be resistance. I'm running, I'm making money, please don't shut me down. I was working for a smaller company, and they made toilet seat covers. Those of you who go to restrooms and gas stations, and et cetera, know that there are dispensers that allow you to put toilet seat covers on the commode so you keep sanitary conditions. Now that is the ultimate commodity business. I mean, these things are pennies per hundred. So to make any money, you've got to keep on running and keep on running and keep on running. The company I worked for was in the toilet seat business, basically as a loss leader. And the material and the apparatus they used effectively looked like it came out of the 1950s. There were no interlocks, there were no safety guides, there were no nothing. And one day, and you can bet, as the operator was feeding paper into the machine, he put his hand where it shouldn't be and got crushed. Fortunately, not badly, but he was injured because there was nothing to stop the machine. There was no interlocks. And I was in charge, in addition to being in charge of R&D, I was in charge of health, safety, and environmental. And through that authority, I shut down the entire toilet seat cover line. I said, we can't run until this is safe. And this got a lot of resistance. CEO came up to me and said, "Hey, Joe, just tell the guys, don't do anything unsafe." And if it was that simple, life would be a breeze. But it wasn't that simple. So we hired a guy who was very knowledgeable in interlocks and those things, and he basically redesigned the control system for all the toilet seat cover machines, and they were fine. It cost money, obviously, but if an operator put his hand in the wrong place, the machine automatically shut down. And it cost 2-3 weeks of downtime, but I was secure in the knowledge that no operator would have his hand crushed in the machine because there are no safety interlocks. And it was good for the company as well, since it meant there would be no OSHA citations, there would be no lawsuits, and so on and so on and so on. These days, safety gets a fair amount of emphasis in most companies. As a new employee, you're drilled on the importance of being safe. You are drilled on the importance of understanding MSD sheets. You are drilled on to understand bills of lading. And even then, it's hard. If you have to get a sample from point A to point B, the temptation is to put it in your trunk and drive it because it's so much more faster than trying to hire, Federal Express or DHL because they usually damage what they ship. But to be safe, the last thing you want is to have a leak and have a state trooper pick you up and find out you've got chemicals in your trunk. Guarantee you're going to be in a lot of trouble, and so's your company. So any good chemical engineer will look at the MSD sheets for the chemicals she's working for, understand the hazards, understand protective equipment, understand the hazards, and conduct oneself accordingly. As an old-time operator told me, he said, Joel, don't be afraid of chemicals, but you better respect them. And that's exactly right. You can't live your life in fear, but you can live your life understanding what you're dealing with and taking the appropriate measures. In my career, I handled peracetic acid. I handled phenol. All these are potentially very nasty chemicals, especially in the concentrations we handle that. But there are ways to handle these safely. You wear goggles, you wear gloves, you wear PPE if you have to. If you get phenol on your hand, you can apply carbowax to it. It just pulls the phenol right out of your skin, and no harm. You will never know anything happened. Respect is key. Knowledge is key. All firms now have very aggressive EHS programs. If someone is injured, it has to be recorded. At the end of the month, there are OSHA statistics that go into the government, and you're rated on your parameters. And if they get to be not so good, you will get a visit from OSHA. And they tend to be rather unpleasant. You're guilty until proven guilty. And the best thing in the world is not to even have them come to your plant. And the way to avoid that is maintaining a safety culture that is absolutely pristine. And that safety culture means understanding your hazards, understanding your MSD sheets, understanding your chemicals, understanding your process. Where are your hazardous chemicals? In what apparatus might you have an explosive mixture if you're not careful? What are your emergency shutdown procedures? If there's a vapor release, what do you do? If there is a leak that is not contained within your dikes, how do you respond? The worst thing in the world is to have an incident, have the local press show up and ask you what happened, and you not being able to answer. These days, the press is extremely aggressive, and they're very, very quick to call out evasive answers. And the worst thing to do is to put out wrong information. Because the first time you're caught in a lie or a half-truth or a misstatement, you are toast. Nobody will ever believe you again, and you'll be on defensive for the entire incident. Union Carbide had several incidents after Bhopal because people were very, very nervous. And at some time, the management made statements that were contradicted the later evidence, and it hurt them. It hurt their credibility. Carbide was never the same company afterwards. The other interesting thing is disposal of hazardous material. Every plant, every unit, every R&D lab generates waste. Can't be helped. Every plant has a waste stream. Way back when, you basically dug a trench, and either set it on fire if it was flammable, or you buried it and hope it would disappear. And many of you may remember the incident of Love Canal in New York City, where a chemical company took its hazardous waste, put it in drums, and buried it in the trench and covered it over. As a case of out of sight, out of mind. That kind of worked until a developer decided to put housing over this abandoned hazardous waste site. And people, of course, who bought the house had no idea what had gone on before. And they began to come down with a variety of pretty nasty diseases until somebody went back to check the records and said, oh, I see what the issue is. And when the EPA started digging, they found these drums, over a period of 20 years, had begun to leak. which is not at all shocking. So it contaminated the air, contaminated the groundwater. It became a EPA Superfund site, one of the first, and gave the chemical industry a really, really bad reputation. In the 1990s, I was having lunch with an executive for a chemical firm, and he said, "Hey, Joel, the way things are so bad now, I think I'd rather be called a pimp than an employee of the chemical industry." Now, he was exaggerating, but it was that bad. It costs you more to get rid of a hazardous chemical than it does to actually make the chemical itself. Chemical goes into a nice drum, it gets labeled, everybody's happy. The waste chemical has to be packaged, has to be labeled, has to be classified, has to be put into a registered transportation, has to be sent to an approved hazardous chemical disposal company. The paperwork is 10 times worse to get rid of something than actually making it, which is why there's such a great emphasis now on trying to minimize waste, trying to make your process as green as possible and as efficient as possible, so that the amount of money you have to spend trying to process waste is absolutely minimized. So one of the companies I work for, it was a very old building, built during World War I, as a matter of fact, had lots of cubby holes and lots of passageways and lots of secret things. And when I came on board, the president of the company said, "Hey, Joe, we're a low waste company." And he's very proud of the fact that they were low waste. And somehow it didn't make a lot of sense to me, since the processes they made did generate waste. So I kind of nosed around and asked my EHS person, how is it that we're a low waste manufacturer? And it turned out that a lot of the stuff was being hidden. It was being hidden in all the passageways, all the cubby holes. So if they made a widespread batch, it wasn't reported. It was simply kind of stored away. So that's an incredibly dangerous situation. So one of my first acts as executive was to find all the hidden caches, classify them properly, and over a period of a year, we got rid of them all. But we couldn't be a low-waste site anymore because it was obvious that we were generating more than was permissible. So these are the many of the traps that you fall into as a chemical engineer in the CPI, trying to deal with safety and hazardous waste. The only way to be ahead of the game, have a rigorous program, a rigorous training program, have people be aware of what the issues are, play the game straight, understand the regulations, and be consistent with those regulations. As onerous and inconvenient as they sometimes are, it's a lot better than having a newspaper man or a TV station show up at your site asking, "What happened?" So, again, Joel Shertok, Process Industries Consultants. I hope that I've communicated with this podcast the concepts of a robust safety culture within the chemical plant. Thank you very much.